IP version 6 and the Gateway Load Balancing Protocol. Let's begin. Our objective for you and I in this MicroNugget is to take a look at the world of Gateway Load Balancing Protocol to understand what it does for us, how it does it, how to configure it, and how to verify it. So let's start off with this guy. What exactly does Gateway Load Balancing Protocol do for us? Well, the answer is it provides fault-tolerant gateways. Now, who needs a gateway? Well, the answer is this guy does. If this computer wants to communicate outside of this local network, 2001 DB8::64, it needs to know its default gateway to use to get out. Now, we can communicate default gateway information in a lot of different ways, but the big part of Gateway Load Balancing Protocol is that once this PC believes that he should use this address as a virtual gateway to get out, then this group of devices, this Gateway Load Balancing Protocol group, can all support that single IP address. So from a visual perspective, if any one of these routers dies and the rest of the group is built to support that one IP address, we have some fault tolerance. And that's the major purpose for any first hop redundancy protocol, whether it's HSRP or Gateway Load Balancing Protocol, is to provide that fault tolerance default gateway functionality for clients. Our next piece is how exactly does it work? Well, once a client believes it should use this address, and there are several ways of convincing a PC that it should use that IP address as its default gateway. We could use static configuration, some flavor or type of DHCP with IPv6, or we can even use auto configuration for this PC to learn that IP address as its default gateway. But once it does, this group of devices all working together as a Gateway Load Balancing Protocol group, they are going to have one of those devices pointed out as the King Kong. I'll call him K-I-N-G, Kong. Now, the official term for him is AVG, the Active Virtual Gateway. And here's what happens. In IPv6, when a client wants to know the layer 2 address of its default gateway, because at layer 2 we still have to forward frames and we still need to know the layer 2 address to send them to, the client is going to send out a neighbor solicitation. And that neighbor solicitation is going to be sent to something called a solicited node multicast group that he believes would have been joined by the router owning that IP address. That's a whole nother story all by itself. But when that request goes out, the active virtual gateway is going to be one of the responders who says, hey, here's the answer you need regarding the layer 2 address of your default gateway. So it's a neighbor solicitation, then we have a neighbor advertisement. And that neighbor advertisement is going to include the MAC address that's associated with that virtual gateway. And here's the big trick, and it's super cool. Every time this router responds, it's going to give off a different MAC address, meaning maybe he sends a response to the first client. He says, okay, use the MAC address 02, which is associated with R2 as an example. And then the next client, will come PC3, makes a request for the same IP address to learn the layer 2 address, and the active virtual gateway sends back the advertisement with, oh, the MAC address is 3. And then again, later to another client, he says it's 4. And maybe to another one, he says it's 1. And each of the devices, each of the routers in Gateway Load Balancing Protocol is providing forwarding functionality for a virtual MAC address, a different virtual MAC address. So when the active virtual gateway hands out the MAC addresses, it's doing round robin by default. So if I have 200 clients and they all came online, 50 of them would think this was the MAC address of the default gateway. 50 of them would think it's this, 50 this, and 50 this. And that way we could do load distribution or load balancing, hence the term Gateway Load Balancing Protocol, across all of the devices. So we still have the benefits of fault tolerance. So if any one of these goes out, one of the other routers will pick up double duty and respond on behalf of his MAC address. So behind the scenes we have fault tolerance, and we also have the benefit of using multiple devices to forward traffic. With Gateway Load Balancing Protocol, we can actually load balance across the group of the forwarding devices. To configure Gateway Load Balancing Protocol, it's interface configuration based. Let's go start on R1's FA0/0 interface. We're going to specify that we want this interface on R1 to join Gateway Load Balancing Protocol group number 1. We're going to specify the virtual address that we want supported. And I'm also going to give this guy a priority of 122 because I want him to be the active virtual gateway. And that's how we can guarantee it. the first device up, which is R1, will be the active virtual gateway no matter what happens. And if a whole bunch of routers happen to boot up at the same exact time and they're duking it out with who gets to be the active virtual gateway, the one with the highest priority is going to win. So if we take a look in just a moment and let this sit for a second while he checks, he's right now checking to verify there's no other active virtual gateway. Then if we do a show of gateway load balancing protocol brief, we can go ahead and see the details. And he says, you know what? Right now, I am the active virtual gateway. That's what this top line is all about. And the virtual address we're supporting is FE809999. And in my group, I have one virtual forwarder. It's himself. And this is the virtual MAC address that he's using. So all by himself, it's pretty lonely. He's the active virtual gateway. He's also the only one of the forwarders. So right now, he would be handing out this single MAC address to all the neighbor solicitations that were trying to find their layer 2 address for the default gateway. So on R2, let's go to interface configuration mode and we'll tell him to join that same gateway load balancing protocol group number 1, same virtual address, and I also am going to specify a priority of 111, just a little higher than the default of 100. And we don't have to specify a non-standard priority, but I'm going to in this case, just so that if this device comes up with a whole bunch of other devices, he'll have the second highest priority in the group and will very likely be the standby router to back up the active virtual gateway should he go away. And in just a moment, we should get a confirmation message regarding the fact that he has listened, he's identified who the players are, and now he is currently going to be active forwarding on the network, and he's also going to be the standby unit for gateway load balancing protocol. And there we have it. So this is for his forwarding state. He's an active forwarder. He's forwarder number 2. And if we do a show gateway load balancing protocol brief, he'll also confirm that he is the standby router for the group. And that's right here. So we have the standby router. The active router, the active virtual gateway, is Mr. R1. And we're supporting that address, and we are the standby router for the group. So router 1 is forwarding for this MAC address, and we are forwarding for this second MAC address right here. Let's add 2 more to the mix. We'll have a group of 4 in our gateway load balancing protocol group. So let's make a road trip over to R3, and on R3, I'm not going to specify a priority here. He'll assume the default priority of 100, and inside of gateway load balancing protocol, there is no default preempt for the active virtual gateway. So once you have an active virtual gateway like R1, no matter what priority we specified, the defaults wouldn't take over that role. So he'll go active here for a second for his forwarding function. He'll also realize who the standby and active virtual gateways are. Let's go to R4 and do the same. And then once these are all done, let's go back to R1 and do a snapshot picture of the whole topology with a show gateway load balancing protocol command with the brief option. So now that will take just a moment for it to converge. Let's go back up here and let's do a show GLBP brief. So at this output, we have group number 1. We have for FA00, this router, which is R1, says I won. I am the active virtual gateway. I'm king of the world. The standby router is this guy. I'm supporting, says R1, this virtual MAC address, and router 2 is supporting this virtual MAC address. R3 is this one, and if we give it just a moment and hit the up arrow key one more time, we should have R4 there as well. So now we are completely set up. I've got 4 devices in my GLBP group. I've got one that's the active virtual gateway, one that's backing him up, and then I've got all the devices assigned as active virtual forwarders for their own specific virtual MAC address as well. Besides the actual show commands to verify the output at the CLI, we could also bring up clients to test them there. The first client, when it tries to find the layer 2 address for the default gateway, it should be given the 01. The second client should be given 02, the last 2 digits of the MAC address. The next client, 03. The next one, 04. And then after that, it would go back to 01. That would give us an equal distribution of the layer 2 addresses. And that's exactly how Gateway Load Balancing Protocol pulls off the magic of load balancing. I've had a great time. For more information on IPv6's Gateway Load Balance Protocol, including some detailed packet analysis of what's happening behind the scenes, come join us in our CBT Nuggets IPv6 series. I hope this has been informative for you, and I'd like to thank you for viewing.